Alright, now in the previous two parts we did some very interesting question on triangle inequality. So we'll be using the two results again, but be careful. You people think that these are easy results, but apparently they have quite a lot of depth in them, right? So definitely you'll be enjoying this part. So let's start. So write on the first one. In a scalene triangle ABC, with integral sides AB as 15, CA as 28, find the number of possible values of side BC. Find the number of possible values of side BC. I want the correct answer. I know it's an easy question, but don't be in a hurry. Because this is KVPY. Again, if you get it wrong, you are going to get 0. Even if you miss by one number, you'll be getting 0. So be careful. Now, a scalene triangle, okay, and the sides are integral, right? Now, what do I know? Now, सबसे पहले इसको मान लेते हैं x. Now, I know that this plus this should be greater than x. The triangle inequality, the three conditions. So, 15 plus 28 is greater than x. Then 28 plus x is greater than 15. Then x plus 15 is greater than 28. Three conditions. Let's utilize it. Now from here I get this is what? 43, right? So x is less than 43. First condition. This is what? X is greater than negative 13. Of course, it is a side. Right. It's a potential name, but okay, fine. And this is x is greater than 30. Right? Okay. So that means x should be greater than 13 and it should be less than 43. 13 less than x less than 43. This is my condition. Now I know that x is an integer. So let me utilize that. So 13 again, 14 ho sakta hai, right? X can be 15, it can be 16, so on. It can be 41, it can be 42. Right? So how many sides these are? How many numbers these are? 14 se 42 tak jana hai. So these are 29 in number. Did you write this answer? If you did, very bad. This is not the correct one. Because you lost something. I said be careful. Easy question, but you commit an error. Now, he says scalene triangle. That means all the sides should be of different length. Okay. 15. Now, if I take my BC to be 15, do you think it will be a scalene triangle? Of course not. That means rejected. Now 28. Now somewhere down the line I will have 28. Now BC definitely cannot be 28. I want the triangle to be scaling. Rejected. So that means 2 extra cases you counted, subtract those. So answer is 27. Alright. I think this was a KVPY question. Jaldi mein 29 likha jata and you get it wrong. So careful. Oh, next. The sides of a triangle, write down, the sides of a triangle are distinct positive integers, in an AP. If the longest side is 153, find the number of such triangles. In bracket, write down non-congruent. Because obviously congruent infinite only. You need to find number of non-congruent triangles. Come on. The sides of a triangle are distinct positive integers. Okay, in AP. Okay, we know what AP is. Longest side is 153. I need to find number of such triangles. Now, if I can ascertain the number of sides, like different triplets of the sides, I should not say triplets because ordering here will not matter. I mean, don't take me too literally here, but basically I'm looking for the triplets of the sides, right? if I can find out how many such triplets exist which will form a triangle, I'll get the number of triangles. Right? Okay. So let me find those. Now the longest side is 153. Right? अब AP में लेने हैं, अब common difference start कर रहे हैं. It might be 1. Right? So first triangle is 153, 152, and 151. First triplet done. Second, common difference can be 2. So 153, 151, and 149. Common difference 3, 153, 150, 147. Right? Then 153, 149, 145. Right? Yeah. And so on. The problem is हम सारे लिख हो गए. Now, check the letter. बीच में कहीं ना कहीं. अब 150, हम 152, 151, 150, 149. अब करते 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 we'll reach 153, 100. Check करें. अब यहाँ पे डिफरेंस कितना है? 53 का. 53 subtract करो, so I'll get 47. I'm checking mentally. Okay. Right. अब check करें. Do you think I can have this triangle? You have 3 lengths. You need to check whether it will form a triangle or not. So check. 100 plus 47. Is it greater than 153? It is 1. So that means this will not form a triangle. No need. इस थोड़ा ऊपर चल जाते हैं. 153. अब 100 था. 101 पे check कर लेते हैं एक बार. Right. 101 पे difference कितना है? 52. So that means this should be 49. Right. Is it forming a triangle? Absolutely not. Not again. इससे थोड़ा और पहले चल जाते हैं. So 153, 102, and that will be 47. Right? 47 होगा? Let me see. इनके बीच में डिफरेंस कितना है? 51 का. 51. My God. 51 का डिफरेंस है ना? हाँ 51 का. इसमें से मैंने 50 अगर मेरे को सब्ट्रैक्ट करना है तो हो जाएगा. My God. You do the calculation. 47 नहीं होगा, ये होगा 51. Stupid I am. Okay, right. 153, 102, and 51. Do you think it will form a triangle? Now 102 plus 51, which is 153. Equal आ गया, अभी नहीं बनेगा. It's okay. इससे पहले वाला देख लेते हैं. Right. So 153, 103, and this will give you 53. Right. So this will definitely form a triangle. और इसके ऊपर वाले, all of them will do. Right. That means from 103, 104, so on to 152. मेरे पास तो markers भी पड़े हुए हैं. Great. 103 to 152. How many numbers are there? अब इसमें भी कुछ प्रॉब्लम आती है. मुझे तो डेफिनेटली आती है. मैं अपना आंसर चेक कर लूं. राइट. अब 101 से 152 तक होता तो मैं बोलती 52. तो 101 and 102 सब्ट्रैक्ट करना है. -2. आंसर इज 50. I calculate like a baby. Right. So answer is 50. Next one, right now. Find the number of triangles. Obviously non-congruent. With all sides as natural numbers. And perimeter 15. Come on. Hurry up. Find the number of triangles with all sides as natural numbers and perimeter 15. So let me take the sides to be A, B, and C. And I know that perimeter is 15. Right? Okay. Start करना है. Basically, I need to find the solutions of this equation, right? But अब तो मुझे triangle inequality भी आती है. अब start करना है. अब now you say, ma'am, fine. Let's take A to be 1, and then we'll take B to be 1. और फिर यहाँ पे हम check करेंगे कितना हुआ 30. Obviously, it will not form a triangle. We will take 1, then 2, and then you take 12. Again, no. And so on. We'll proceed like this. A good method. But maybe we can go for something better, right? अब जरूर है ऐसे counting करनी है, ऐसे भी कर सकते हैं. Which is beneficial for me, I will do that, right? Now, definitely I want A, B, and C to form a triangle. right? That means sum of those sides should be greater than the third one. So can you tell me what will be the maximum length of the side? Maximum length. Will it be 1? Of course not. 2? No. 3? Maximum booster 1. Maybe I should say it is 7. Why? Because if this is 7, this is 8. Right? I cannot increase it to 8 because अगर ये 8 हो जाएगा, ये 7 हो जाएगा. Sum of two sides. It has to be greater. Right? So maximum length possible is 7. So that's it. अब try करते हैं. अब बनाते हैं जल्दी से. So this is 7. So I'll take it to be 1 and this I can take 8 हो गया 7. 7 1 7 done. 7 2 6. Another. 7 3 5. Another. सबके लिए बन रहा है. Don't worry. 7 4 11 हो गया ना 4. Right? Again. 7 5. Oh 7 5 वाला मैंने already ले लिया. दोबारा नहीं लूँगी. Congruent नहीं चाहिए मुझे. So separate one. 7 5 के बाद 6 but already included. Is 7 7 already included. Right? So 7 exhausted. Next. Let's take this to be 6. अब 6 के साथ 7 वाला मैं केस बिल्कुल नहीं लूंगी. मैं कर चुकी हूँ. नहीं ऐसे ही चलते. 6 के साथ 1 स्टार्ट करते हैं. Now if this is 7, this has to be what? अब यहाँ पे आ जाएगा 8. Right? 7 to 6. But that is a problem. It will not form a triangle. Okay, no need. So यहाँ पे आ जाता है then 2. Then that will be 7. But already included. So then it will be 3 and 6. 3 12. Yeah, this will be 1. सबके लिए बन रहा है. Great. Then 6 4 5. कहीं include किया? No. This is one case. Then 6 5 वाला consider कर चुकी हूँ. 6 7 already done. So 6 1 done. Now let's start with 5. अब 5 1 के साथ तो definitely नहीं बनेगा. 5 2 के साथ भी नहीं बनेगा. 5 3 के साथ 7 बनता है but already included. Right? Then 5 4 already done. Then 5 5 5. अच्छा ये कहीं किया? No. Another one. Then 5 6 already included. 5 7 already included. And rest of them I will not check only. Why? 4 से 4 मैंने सबके साथ कर लिया. 7 के साथ possibilities थी. 6 के साथ थी. Done. Right? So if you want to check, you can. But common sense says you will not find any more triangles. So if you want to waste your time, do it. I mean, obviously just don't. But okay. So how many triangles? 1 2 3 4 5 6 7. You will find 7 triangles with perimeter as 15 and sides as natural numbers. Done? Ooh, next one is very interesting. Now the interesting part of the lecture, I would say. The next 3 questions are incredibly interesting. You're definitely going to enjoy. So write down. If P is any point on a straight line, if P is any point on a straight line, drawn through the vertex A, of an isosceles triangle ABC, parallel to BC, prove that PB plus PC is greater than AB plus AC. I'll repeat. If P is any point on a straight line drawn through the vertex A of isosceles triangle ABC, excluding A, that means P can be any point on that line excluding A, parallel to BC, so straight line is parallel to BC, prove that PB plus PC is greater than AB plus AC. First of all, obviously, draw the diagram, understand it, and then find your triangle. So isosceles triangle ABC. A, B, C. Now through A, I have a line parallel to BC. So this is a line parallel to BC. Right? Now I need to locate the point. Locating, if P is any point on this line. Right? Okay. You need to prove PB plus PC is greater than AB plus AC. You need to prove this. Now, PB plus PC, so definitely मैंने join तो किया होगा. Let me join. Let me join. So PB plus PC is greater than AB plus AC. And what do I know? That ABC is an isosceles triangle. That means these two sides are equal, these two angles are equal. This is parallel to this. Now, triangle inequality. PB plus PC. PB plus PC. अब इस triangle में involve तो हो रहे हैं. Got it. But on right hand side, I have AB plus AC. AB यहाँ पे, AB यहाँ पे. Now clearly, not even single triangle. Single triangle में involve नहीं है. क्या करें? क्या करें? Somehow, I need to have all of these sides in a single triangle. Check करें. Now, PC. अब PB को तो I will not be touching. नहीं touch करते. PC को translate करते हैं. Let me translate PC. Right? And before translating, let me do one thing because the diagram is not that nice. Let me take P further so that you can actually see. So let me take P here. Perhaps now you'll get the hint. Right? Now, PB I'm not touching. PC I'll translate. Now, if I want to translate, the easier method is the method of reflection. So this point, C. Take the reflection of C in this line. This line. Right? So जितना ये था उतना ही ऊपर. Clearly उतना ऊपर नहीं है. I should make it again. You want me to make it again? As if you can answer me. But okay, fine, I'll make it again so that you can, yeah, it would be better, I guess. So I should not, okay. Making the diagram again. People, if you make wrong diagrams, please make it again because through diagrams you are able to understand the problem again. So don't be shy, don't be lazy in this part at least. Diagram दोबारा बनाना है, you should do that. Right? And then I will take P far apart. Done. Okay, this is parallel to this. I need to prove P plus PC is greater than AB plus AC. Right? PB. Now, what I am trying to do is I am translating this line by reflection. Let's see. So, C, take the reflection of C in this line. Oh, great. Right? So, जितना गया था उतना ही ऊपर. Now, it seems like good. So, this point C dash is the reflection of point C in this line. Right? Now, if I join P and C dash, can I say that this length is equal to this length? Of course. Come on, this is the common side. These two are equal, 90 degrees. This triangle is congruent to this one. So, PC is equal to PC dash. Done? Okay. Translate to हो गया. Now, PB plus PC चाहिए था. Now, I'll talk about PB plus PC dash. But मुझे तो AB plus AC चाहिए. Now, what I'll do is, I will join A with C dash. Right? Now, the problem is, PB is here, PC dash is here. Now, this is AB. अब मैंने join किया. First of all, I am not sure whether this is a straight line or not. Right? अब सबसे पहले तो वो देखना ये straight line है भी नहीं. Then only I can say that BPC dash is a triangle, provided this is a line. ये straight line है या नहीं वो कैसे पता चलेगा? I will try to prove that and here it forms a linear pair. Prove करें? अब linear pair कैसे prove करें? Let's see. अभी तक मैंने isosceles triangle का use नहीं किया ना? I'll use that. Now AB is equal to AC, right? So that means this angle, suppose this is theta, this angle is also theta. Now these two lines are parallel, right? This is the transversal. This and this will be equal, right? Alternate angles. Also, we can clearly see that this triangle is congruent to this one, isn't it? This is equal to this. Common side 90 degrees, right? So that means if this angle is theta, can I say that this angle is also theta? Okay, this is एक और भी benefit हो गया. This triangle is congruent to this one, right? That means this is equal to this. अच्छा, हम तो linear pair prove कर रहे थे, हमें additional advantage हो गया, we'll deal with it. It's okay. अब मुझे prove करना है यहाँ पे 180 डिग्री बन रहा है. अब somehow I need to prove that this angle is 180 minus 2 theta. If I am able to prove that this angle is 180 minus 2 theta, the sum of angles is what? 180. Linear pair. This angle, 180 minus 2 theta. Oh, वो तो हो गई. Triangle ABC, this is theta, this is theta. Definitely this is 180 minus 2 theta. So I can say that this is a straight line. Right? So in triangle BPC dash, BPC dash. Now, मुझे चाहिए था PB plus PC. So PB plus PC dash. PC dash or TC same है. Now, this plus this is greater than BC dash. अब मुझे चाहिए AB plus AC. तो BC dash को क्या लिखते हैं? AB plus AC dash. AB plus AC dash. पर मुझे तो AC चाहिए. Obviously, अब AC dash is equal to AC. अभी तो proof किया. This triangle is congruent to this one. Right? So this is nothing but AC. तो ठीक है, यहाँ पे PC dash की जगह PC लिख लो, done. Hence proven. Just one step of construction. You just needed to translate this length to here, so that you can get all these as these sides basically, all these sides as a single triangle. Just one step of construction. That's it. You need to choose where you have to utilize the construction part. The most interesting one. Think about it. Translate करना है कैसे करें? हाँ, maybe reflection. Right? Let's see. Next one. Next one is also very, very interesting. Write down. Show that sum of any two medians of a triangle, is greater than the third median. Is greater than the third one. Come on. A brilliant question, I would say. Okay, so let me have my triangle ABC first. And I want medians. So AD is the median. This is equal to this. DE is the median. And obviously through this point, I will have my third median, which is CF. Now, I want to show that sum of any two medians is greater than the third one. So, any two में ले लेते हैं AD and then I take DE. Sum should be greater than the third one. Right? Now, AD, BE, then CF. My God, these are definitely not in the same triangle. How will I apply triangle inequality? One is here, one is here, one is here. Same triangle में नहीं है. Okay, what do I do? Just think about it. Medians then. Three medians are getting involved in the triangle. Okay, what is the special point related to medians in the triangle? Circumcenter. No. Incenter. No. Orthocenter. No. Starts with C. Centroid. Right? Point of intersection of the medians is called centroid, and I think we denote it by G. Now, this is a very nice point, isn't it? What does it do? Centroid divides the median in the ratio 2:1. Right? That means AG ratio GD is equal to 2/1. Right? And BG ratio GE is 2:1. And CG ratio GF is 2:1. Now you will say, ma'am, what are we talking about? Okay, we know this, but we need to prove this. Now the problem is, I am a bit hesitant of involving the entire length AD, because AD यहाँ पे, BE यहाँ पे, definitely single triangle में, it will be very difficult. Right? So maybe I can use a part of AD rather than the entire one. right? So मैं AG involve कर लेती हूँ. What I do is, instead of proving this, I try to prove that 2/3 AD plus 2/3 BE is greater than 2/3 CF. Why would I do that? Because 2/3 AD is what? 2/3 AD is nothing but AG. And 2/3 BE. 2/3 BE is nothing but BG. And 2/3 CF is nothing but CG. I need to prove this? I'll prove this. No, I'll prove this. I'll prove that AG plus BG is greater than CG. What is the advantage? AG plus BG is greater than CG. At least AG and BG same triangle में तो है. Something happened, right? Okay, something happened. एक triangle में आए. But now you say हम CG तो यहाँ पे है कि कैसे करेंगे हम? Good question. Good question. What can we do now? What can we do? अब AG BG इस triangle में रहना है, but ये length चाहिए somehow generate करनी है. Now tell me again. G divides the line segment in the ratio 2:1. 2:1. Now somehow what I'll do is I will extend this. मुझे CG आनी चाहिए. यहाँ पे बना लो CG. Maybe it will help me. अब ये 2:1 है. अगर सपोज ये 2x है, this is x. मैं यहाँ पे 2x बना लेती हूँ. x है, extend GF to the length. What? ये पॉइंट बोलूँ कौन सा पॉइंट यूज नहीं हुआ? G हो गया h. Extend GF till h. GF to h such that GF is equal to FH. GF is equal to FH. अब मैंने बहुत ज़्यादा नोटेशन यूज कर दी ना, इसको यहाँ से हटा दूँ, so that I can use it here. This is equal to this. Why? Because if this is x, this is also x. That means this length GH becomes 2h. अच्छा 2x क्या था? CG? हाँ, so basically GH becomes equal to CG. Translate कर ली. यहाँ पे थी, मैंने यहाँ पे बना ली. No, you say no. Benefit? Maybe there is a benefit. Just look at it. हाँ, अब इसको यहाँ से हटा देते हैं. This is equal to this. This is equal to this. Now consider this quadrilateral. AHBG. AHBG. Diagonals. Diagonals. Diagonals bisecting each other. What kind of quadrilateral is this? AHBG is a parallelogram. Right? So maybe I can help out now. Parallelogram है. अब मुझे क्या चाहिए था? AG plus BG. अब AG तो यहाँ पर है. अब BG यहाँ पे था. But parallelogram है. This length will be equal to this length. Right? So अब मुझे prove करना था AG plus BG. Right? Instead of that, I'll prove that AG plus AH. AG plus AH. अब should be greater than CG. अब CG किसके equal है? HG. So I'll prove that AG plus AH is greater than GH. I need to prove this, which is trivially true. क्यों? Consider triangle AGH. Sum of two sides is obviously greater than the third one. Triangle inequality. So the step of construction was very important. Also, the importance of centroid. It's a very nice point. Divide the median in the specific ratio. Utilize it. Class 9th you have studied it. I will give you 5 seconds. Just revise it. These two steps are very important. The construction part, first of all 2/3 construct करना था. Then CG को translate करना है. इसको double कर दिया. So that this is equal to this. अब वैसे भी usually, no, I should not say this, but this is equal to this, right? जब ये चीजें आती है वो diagonals में, this sort of construction is very important. Parallelogram बन जाता है. Usually. Right. Oh, so the next one. Next one is also very interesting. So write down. Prove that of all triangles with a given base and given vertex angle, An isosceles triangle has the longest bisector. An isosceles triangle has the longest bisector of the vertex angle. First of all, understand the question, what he's asking, and then proceed. Trust me, it is a very interesting question. Okay, let's read it. Prove that of all triangles, you need to consider all triangles apparently, with a given base and a given vertex angle. So base is given to you. Suppose this is the base, this length is given to you, and vertex angle is given. Right? Now first of all, you can find many triangles. Right? With this base, ये angle बनाना है, एक यहाँ पे होगा. Right? Then maybe I can have it here. Maybe I can have it here. Right? Now, can you tell me where these vertices lie? Right? This angle is equal to this angle is equal to this angle is equal to this. These are the lines. And these the angles in the same segment, people. So basically, all these points will lie on a circle. And this will be the chord of the circle. Right? Now he says, of all the triangles, basically of all the triangles, because you can make obviously infinite angle in the semicircle, angle in the same segment. So of all these triangles, and isosceles triangle. Okay, so let me make it again now. So this is my base, and I'll consider just one for the sake of convenience, this triangle. Then I'll consider on this base the isosceles triangle. So isosceles triangle would be something like this. Right? He says that this angle is equal to this angle, vertex angle are equal. He says that this triangle would have the longest angle bisector. Right? This angle bisector would be this. Now let me name this. So A, B, C, D, E, F. So A, B, C is an isosceles triangle and C, D is the angle bisector. And in the triangle A, E, B, this is equal to this. And EF is the angle bisector. He says that the isosceles triangle angle bisector, as in CD, will definitely always be greater than the angle bisector of all the other triangles. Basically, CD will always be greater than AF. You need to prove that. So what I have done is, I have taken an arbitrary triangle. If I am able to prove in this case that AD is greater than CS, CD is greater than EF, my job will be done. I'll be able to prove that the angle bisector of an isosceles triangle is the longest one. So do we understand the question? Till now we have just been understanding the question. Right. So now proceed. Now think of ways how to go on about it. And maybe you can use a circle, because the vertices lie on a circle, right? First of all, I should make the circle easy. Make the diagram easy, right? So I'll cheat a bit. People don't look at my figure till the time I'm done, because I will cheat. No, make it. First of all, I'll make my isosceles triangle. Then the secondary one. Right, so A, B, C, D, then my angle bisector. This is E, and my angle bisector. This is F. This is equal to this is equal to this. Right, and what do I know? Let me write it. So angle D is equal to angle C. Right, I know that triangle ABC is isosceles, whatever you want to call it. That means AC is equal to BC. What else? AB is the common base. I need to prove that CE is greater than DS. Always. Right? I also know that these vertices lie on the circle. right? Okay. हाँ मुझे ये prove करना है. How should I go on about it? Now, first of all, whatever you can notice, just note it down. Of course, whatever you can observe, just look at the figure and intuitively what you feel, just find it out. Now, first of all, what I feel is, since this is an isosceles triangle, can I say that if I extend CE in order to meet the circle, this length is nothing but the diameter. So I'll say that CG is the diameter. Can we justify why? Intuitively it seems like it. Why CG is the diameter? Come on. Diameter as in center will lie on this line, right? अब isosceles triangle है. The angle bisector और median भी होगा. AE will be equal to EB and 90 degree बन रहा है. That means center has to be here because perpendicular bisector of the chord will pass through center, right? So center lies on this line. So basically CG is the diameter. Okay, understood. Now what else? What else I can figure out? Now also it seems like if I extend DF, doesn't feel like it. मेरे केस में तो बिल्कुल नहीं बन रहा है. Okay, let me cheat again. Yeah. It seems like that if I extend DF, it will definitely pass through G. Doesn't seem like. अब मेरे डायग्राम में देखो, मेरे डायग्राम तो बहुत ही खराब है. Why? Let's say, but you need to justify also. Why do you think that DF will pass through G? Why do you think that? Or maybe you don't think that, but I think. Why? Let's see. Why will it pass? Now I know that DF is what? The angle bisector. Right? Now this arc is subtending this angle. Right? And this arc is subtending the same angle. Now first of all, be clear about this. Can I say that G is the midpoint of this arc? Right? Because this and this, these are equal. Right? I know that equal arcs subtend equal angles. So these two are equal. So G has to be the midpoint. अब तुम बोलोगे मैम G आपको कैसे पता? वैसे midpoint तो होना था. Isosceles triangle को तुमने extend किया. Again, this angle is equal to this angle. Right? Arc angles are equal. Right? Definitely midpoint पे ही आना था. इसको भी join किया ये तो midpoint पे ही आना था. अब इसका इस AB का एक ही midpoint होगा, right? If I consider triangle ABC, this is the arc, this is the arc. So G is the midpoint of this. Again, AB का यहाँ पे this midpoint पे ही आना था, right? Intuitively. Figure में नहीं लग रहा है, but okay. Right? Okay. What else? You will be like, ma'am, what are you doing? You need to prove that CE is greater than DS. Okay. Now, what inequalities I know? First of all, write that. Now, can I say, no, what can I say? I know that CG is the diameter. And diameter is the longest chord. It is longer than any other chord. Now, clearly, DG is the chord, right? So, can I say that CG will be greater than DG? Diameter is always greater than any other chord, right? Okay. Now you will say, ma'am, we need to talk about CE. You have gone to CG. Okay. What else do I know? What else? Achha, ABC is an isosceles triangle, right? Can I say that this angle is 90 degrees? Achha, bolo. Angle bisector hai, median hoga. I just told you, right? This angle has to be 90 degrees. Now 90 degree mein, I know that the hypotenuse is always greater than the side. That means FG, because मैंने DG involve किया, अब FG involve कर लेते हैं. FG will be greater than EG. Hypotenuse greater than the side. FG greater than EG. Right? CG. मैंने कुछ गलत तो नहीं कर दिया? नहीं. Doesn't seem like it. मुझे प्रूव करना है CE CG minus FG. DF मुझे minus चाहिए था. Okay. We'll deal with it. We'll deal with it. Okay. Alright. Right. Cool. Not a big deal. Right. अब ये यहाँ तक पहुँचे. Somehow मुझे CE बनाना है. Right. CE बनाना. अब चेक करें. अब इन दोनों से CE बनाने के लिए सबसे पहले I'll add the two. Left hand side add CG plus FG is greater than DG plus EG. मुझे क्या चाहिए था? CE. That means CG minus EG चाहिए था. Minus. Side change कर लें और maybe we can say subtracting EG on both the sides. Right? So CG minus EG. ये कर लिया. Plus FG greater than DG. ये EG तो disappear because minus EG किया. Right? Now, I wanted DF. That means I want DG minus FG. Minus FG. So subtracting FG on both the sides. So subtracting FG, gone. Subtracting FG. Right? CG minus EG. CG minus EG is nothing but CE. And this is greater than DG minus FG, which is DF. Hence, true. Now you say, ma'am, you didn't use triangle inequality. We have been using that. I just want to point out one thing, that inequality can be used in different methods as well. You know this, that diameter is the longest chord. You know that the hypotenuse is greater than the side. These are also the inequalities in a triangle. You can use that. Just because you learn two results doesn't mean you can forget the rest of them. Right? So use whatever you have in your arsenal. Right? So that's the end for today's lecture. Now, homework. Homework is a very interesting thing this time. So you should buy this book, or maybe you already have it. Mathematical Circles. Oh, I should have got it with me, right? Now, Mathematical Circles, please buy it because pehli baar to homework karna hai. There's a chapter called Triangle Inequality which you need to complete. It is a beautiful chapter and it has some really interesting questions where you will learn how to utilize constructions, right, which we usually tend to ignore, but those are very important questions, right? So please buy Mathematical Circles and do the chapter Triangle Inequality, right? Also, I would recommend please read the preface of the book because then you'll get to know what kind of kids or what kind of students are reading this. So basically this is a Russian book and it is meant to be for 13-year-old Russians. So 13-year-old Russians, 16-year-old Indians, I think we can definitely compare. In fact, you people are at advantage. So you better be doing this book. 13 years, basically I'm giving you a kid's book. So please do it. It's a very interesting book and definitely we'll be taking up the doubts from this. So that's it for today's lecture. I will see you next time. Thank you.